Hey everyone, and welcome back to Idea Mechanics. There's a huge hidden problem in the software world, and that's waste. Today, we are ditching the guesswork. We're going to dive deep into systematic innovation with a powerful tool called TRIZ. And leading the charge, as always, is our lead innovation catalyst from Idea Mechanics. He's here to show us how a simple principle from physics can totally change the game for software design.
So let's get right into it. Think about this. A massive database running at full power at 3 a.m. when nobody's using it. It's just incredibly wasteful, right? We call this the static trap. It's like keeping your foot on the gas of a Ferrari while it's parked in the garage. All that wasted energy, all that wear and tear for absolutely nothing. If you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next. All right, so how do we actually get out of this static trap? Is there a systematic way? Absolutely. And our navigator here is pointing us right to the answer. TRIZ Principle 36, Phase Transitions. This is where things get really cool. We're going to learn how to build software that doesn't just run at one speed, but actually adapts to what's happening around it.
So what exactly is a phase transition? Well, the concept comes straight from physics, and it's actually super simple. Think about water. It can be a liquid, right? But it can also transition into a solid, ice, or a gas, steam. Each change of state, or phase, involves a massive change in energy. Now, what if we could take that same powerful idea and apply it to our software? And this really gets to the core of the mindset shift we need. You see, the old way on the left? That's static operation. One single, rigid state, always burning full power. But the TRIZ innovator, well, they ask a totally different question. They ask, how can my system change its state, its phase, to perfectly match what's needed right now? It's a total shift from being static to being dynamic.
Okay, enough theory. Let's see this in action. For our first case study, we're going to look at what we're calling the shape-shifting database. This is where the rubber really meets the road.
So here's the fundamental problem, the contradiction we need to solve. How can a database give you maximum performance whenever you need it, but at the same time achieve minimum energy waste when you don't? It feels like you can't have both, right? Well, the solution is to actually engineer a phase transition, and our navigator is breaking down the steps for us right here. First, the system detects a trigger, say a huge drop in user requests. That kicks off the phase transition, where the system starts to shift its whole mode of operation, and finally it lands in a brand new state, like a super efficient low-power mode. And the win here is massive. Instead of a dumb, rigid system, you get something that's smart and adaptive. It's a system that can actually react to its environment in real time. We're talking huge savings in energy costs and less wear on your hardware, all happening automatically. All right, let's look at another example, one that you probably use every single day without even thinking about it, the hibernating OS on your laptop. This is just a perfect example of solving that kind of tough contradiction. And what's the contradiction here? It's the classic battle, performance versus battery life. You need your laptop to be a beast when you're doing heavy work, but you also need that battery to last the whole day. If you leave it running full tilt, the battery dies in no time. But shutting it down completely means you have to wait forever for it to boot back up. So how do modern operating systems solve this? You guessed it, with a phase transition. As our navigator shows, when the system sees you're not using it, that's the trigger. The OS then begins to transition from its high-performance state into a totally different phase, sleep mode. In this new state, it sips power, using almost nothing, but it's ready to wake up in a split second. The innovation here is just brilliant, isn't it? The laptop saves a ton of energy, stretching your battery life for hours, but it doesn't sacrifice that instant-on responsiveness we all love. It's the perfect balance of power saving and readiness, and it's all thanks to this state-shifting idea. Okay, let's wrap this up with the innovator's final lesson, because what we've been talking about, it's not just a coding trick. It's a whole new way to think about how we build, well, pretty much any system. So here's the big lesson from TRIZ 36. Number 1, your software doesn't have to be rigid. We can actually design systems to freeze into a low-power state to save resources. And then, this is the magic part, we design them to instantly melt back to full power the second they're needed. That's how you build truly smart, adaptive software. And this quote really says it all. True innovation isn't about tacking on more features. It's about fundamentally rethinking how things are built. It means we have to stop building systems that only know how to run at one speed. So I'll leave you with a question to think about. Look at the systems you're working on right now. Where are you stuck in that rigid one-speed mindset? And more importantly, what new phase does your system need to unlock to take it to the next level?